ready to dive into something new. Today, we're all about that spark of innovation. We've got this lecturer, a chemical engineering professor, and man, he really gets into
Oh,
it.
yeah, it's like you're right there in the lecture hall with him, The
Oh,
energy is contagious.
totally. He starts off strong, too, talking about innovations that have, like, changed the course of history. He brings up the Haber process, for example.
Right. The Haber process, where would we be without it? It's this amazing process for making ammonia, which is like the backbone of fertilizer. Think about it. Feeding billions of people. That's
Yeah,
a big deal.
huge. And he ties it into this idea of, like, the attractiveness curve of technology, how inventions become irresistible when they solve a problem that really, really matters.
Exactly. It's like beta blockers come along and boom, suddenly we're treating heart disease in a whole new way. It's attractive because it means healthier lives, longer lives. You can't argue with that.
It's like, okay, you've got my attention.
Yeah.
And speaking of life-changing innovations, he brings up in vitro fertilization. We're talking about addressing something so deeply personal, so important to so many people.
Absolutely. And it shows you the power of science to offer hope where traditional methods might not be enough. It really challenges this idea that innovation is just about fancy gadgets or whatever. It's about real human needs, real solutions.
Totally. But then he takes this really interesting turn. He starts pushing back on this notion that every amazing invention has to come with a Nobel Prize or a patent. He dives into this world of unsung heroes.
Yeah, the people who maybe didn't get all the accolades, but whose inventions have had a huge impact, like Russell O.
Right. The guy behind photovoltaic cells, P-junctions. I mean, that's the foundation for solar panels, right? We see those everywhere now.
Everywhere. Or take Narendra Kapani. His work on fiber optics was revolutionary. He was basically laying the groundwork for the future of communication, and way ahead of his time.
It makes you realize that innovation is happening everywhere. You know, it's not always in some fancy lab. And he takes it even further, saying that you don't even need, like, a lab or millions of dollars to be innovative. He calls it street smarts. Like this story he tells about a driver who uses his hand as a makeshift dog bowl.
And it works. It's that simple, right? It's just resourcefulness, observation, finding a solution on the fly.
It's like necessity is the mother of invention, right? And he gives another example, like using bath water for more than one thing. I mean, I've totally done that. Water the plants, maybe do a little cleaning.
Of course. Making the most of what you have, it's all about being resourceful. And that's where he starts to dig into what really drives this kind of creative problem solving. And that's when he introduces this whole concept of asymmetric gains.
Asymmetric gains. Okay, yeah, that one got my attention too. Sounds kind of, I don't know, kind of strategic or something, right?
It is. It's all about aiming for those innovations where a small input leads to a huge output. Like you put in a little, but you get a lot back. Finding those leverage points where a small effort can make a big difference.
Okay, yeah, that makes a lot of sense. It's like the ultimate efficiency hack. But how does this asymmetric gains thing actually work in the real world? Any good examples?
Oh, tons of them. Think about the wheel, right? It's such a simple concept when you think about it, but it changed everything. Transportation, industry, you name it. Or the printing press, right? One invention, and suddenly knowledge is everywhere, communication explodes.
Wow, yeah. It really puts those asymmetric gains into perspective, doesn't it? But I imagine it's not always easy to, like, spot those opportunities. How do you even begin to look for something like that?
Well, that's where the professor brings up this really cool problem-solving framework. It's called TIZ.
TIZ, right? Yeah, yeah, it rang a bell. Sounded kind of technical, though, if I'm being honest. Is this something like only engineers can use?
Not at all. It was developed by an engineer, Jen Schuler, but the cool thing about it is it can be applied to all kinds of problems. And the basic idea is that most problems, no matter what field they're in, they all involve some kind of contradiction.
Contradictions, like wanting to have your cake and eat it too, that kind of thing.
Exactly. Or maybe something a little more practical, like wanting to increase efficiency but also cut costs at the same time. So TRIZ gives you this structured way to analyze those contradictions and figure out how to overcome them.
Okay, so how does that actually work in real life? Got an example?
Remember that engineering example he gave, the one about designing heat exchangers?
Yeah, where, like, increasing the turbulence makes the heat transfer better, but then it also leads to, like, higher pressure drops. It's like
Yeah.
you're stuck between a rock and a hard place.
Exactly. So TRZ would say, okay, don't just settle for a compromise here. Look deeper. Instead of choosing one or the other, try to find a way to get rid of the contradiction altogether.
So it's like you're not just trying to have your cake and eat it too. You're trying to figure out how to bake a cake where you can actually have both.
Exactly. TRAZ is all about finding those win-win solutions. It's about breaking free from those old ways of thinking and coming up with something truly innovative.
I like that. Reframing the problem, right?
Yeah.
But let's be real, not every innovation is going to change the world. Sometimes it's about protecting your idea, right?
Mm.
Even if it's just for like a new product or a new business or something. And that's where patents come in, right?
Absolutely. And the professor, he really gets into the nitty-gritty of patents, too.
Yeah, because on the surface, it seems pretty straightforward. You invent something, you get a patent, it's protected. But it's obviously not that simple.
Not quite. He actually calls patents a double-edged sword.
Meaning?
Well, on the one hand, they do give you legal protection, which is huge. But to get a patent, you have to, publicly disclose how your invention works, all the details.
Which seems kind of counterintuitive, right?
Yeah.
Like you're trying to protect your idea, but you have to tell everyone how it works.
Right, and that's the dilemma, because now you've put that information out there, and your competitors, they can see it too. They might find ways to, replicate your idea or get around your patent altogether.
This is a real balancing act then, right? You're
Oh.
weighing the benefits of having that protection against the risks of someone, using your own invention against you.
Exactly. It's this whole strategic decision, and it's something that a lot of people don't really think about.
It's like that saying, information wants to be free, but in the real world, there's all these other factors to consider, right?
Absolutely. Legal stuff, business stuff, strategy. It's not just about the invention itself. It's about understanding the whole landscape. And that's something the professor emphasizes throughout this whole lecture. Innovation, it's not just about having these brilliant ideas.
It's about navigating the real world, figuring things out as you go, making decisions, taking risks. It's funny, we've covered so much ground, these big world-changing inventions, the unsung heroes, even like the legal side of things with patents. But honestly, what I keep coming back to is how much the professor focuses on mindset. Like you don't have to be some genius to be innovative.
Totally. He actually says that straight up, that it's a myth. He says it's more about cultivating that inquisitiveness, never losing that kind of childlike curiosity about, why are things the way they are?
Oh, yeah, 100%.
Yeah.
I'm always the one asking why, even when people are probably sick of it.
Yeah.
But that's how you learn.
Exactly. It's about embracing that constant search for a better way. How can we make this better? Even if it's a small thing,
Right. And he also talks about how it's not always about one brilliant person working alone, especially with those really big problems. Collaboration is key. He brings up the Haber-Bosch process again as an example. Huge collaborative effort.
Makes sense, right? You get all those different minds together, different perspectives, different areas of expertise. It's like the sum is greater than, the whole is greater than the sum of its parts, something like that.
Exactly. And then towards the end there, he kind of throws down the gauntlet, He's like, all right, what are the big problems you guys see? What are the big opportunities for the future? And they actually have this really cool brainstorming session.
Which is great because it gets real, He's asking them to take these principles and apply them to actual challenges, and they come up with some really interesting stuff. Alternative energy was a big one.
Yeah, and they get into those tougher questions too, right?
Yeah.
Like, how do you make alternative energy affordable, accessible, realistic? It's one thing to have an idea. It's another to actually make it work in the real world.
Totally. And then there's the whole circular economy thing, which is, it's a huge challenge, but it's also a huge opportunity.
Yeah.
It's about moving away from that take, make, dispose model and figuring out how to reuse and recycle stuff, especially plastics.
Yeah, plastics are a whole other beast. And of course, they talk about carbon capture, which, how could you not? It feels like climate change is the biggest challenge of our time.
Absolutely. And the professor, he makes this really interesting point that planting trees, it seems so basic, right? But it's actually one of the most effective methods we have right now for carbon capture.
Right. Sometimes the simplest solution is the best, but he also wants them to think bigger. He throws out this question, why not the oceans? Don't be afraid to think differently. Challenge assumptions.
And they even touch on biotechnology, which is, who knows what the limits are there? It feels like it could change everything from healthcare to how we manufacture things.
Right. It's amazing to think about how all these different fields are interconnected. A breakthrough in one area can have this ripple effect across a whole bunch of others. And they even talk about rethinking everyday products, everyday processes, finding ways to separate materials, using less energy, which has huge implications for manufacturing, or even just like redesigning packaging so there's less waste.
Exactly. Innovation isn't always about inventing something totally new, right?
No.
Sometimes it's about looking at what's already there and saying, okay, how can we make this better? How can we make it more efficient, more sustainable?
Right, exactly. And at the very end, the professor, he brings it all back around to a more personal level. He tells the students to look at their own lives, their own experiences, and find those areas where they can, like, contribute, even in a small way.
It's a really nice way to end it, I think. Like, you don't need permission to be innovative. Start with what you know, what you're passionate about, and see what happens.
I love that. He actually leaves them with this question, which I think is a good one for all of us. What's that seemingly small problem, maybe one you've even encountered in your own life, that you could try to solve?
It's like a call to action, right? Look around, find those challenges, and instead of just accepting them, see if you can come up with a better solution.
Exactly. This whole deep dive has been such a great reminder that innovation isn't like this magical thing that only certain people can do. It's a skill, it's a mindset, it's a way of looking at the world, and we can all cultivate that. So, next time you run into a problem, big or small, don't just accept it. Ask why, and then see if you can find a better way. You might surprise yourself.